In this video tutorial, I am going to discuss about chemistry of triacylglycerol. This triacylglycerol, it is known by many different names. One of them is triglyceride. It is also known as neutral fates, or simply sometime it can only referred as a simply fates. Okay, so let's see what is this triacylglycerol. Triacylglycerol. The tri means 3. Acyl, it is a hydrocarbon chain, and we know that one compound in lipid which is related with the hydrocarbon chain, it is fatty acid, and the glycerol is the trihydric alcohol. Okay, it is one compound which is known as glycerol and which is a trihydric alcohol. It is a trihydric alcohol. So by the name we can get some idea about the structure of glycerol. So that means this glycerol, this compound is bound with 3 different fatty acids. So let's try to understand this structure of triacylglycerol. So first we know that glycerol is a 3 carbon long compound and it has 3 alcohol group, that is OH groups are there. And remaining position we have to fill it with the hydrogen. So this is a glycerol. Now it binds with 3 fatty acid. So we know the typical structure of fatty acid, that on one end it has COOH group, it's a long aliphatic chain of hydrocarbon, and on another end it contains methyl group. So such 3 fatty acids are there. Suppose this is fatty acid 1. Similarly, we have second fatty acid. So this is fatty acid 2 and this is third fatty acid. So we call it as a fatty acid 3. When these 3 fatty acids bind with one glycerol, then what will happen? Then the OH group, out of this OH group, this hydrogen, okay, with this hydrogen, and from this COOH group, these OH atoms, these are removed. So what will happen? This OH and this hydrogen gets bound and removed. So it forms the H2O. The same thing will happen with this part also. The same thing will happen with this third fatty acid also. So total 3 molecules of H2O comes out. And then what will happen? This oxygen makes up a bond with this carbon. So let's draw its structure. So first these 3 carbons are intact. Its hydrogen are also there. And now as from this OH, this hydrogen is removed. So I write simply O. Okay. Now see, this hydrogen is removed and this OH is removed. So this oxygen makes up a bond with this carbon. So it is like this. So what happens to this oxygen? It remains there by the double bonding with the carbon, and then the rest of chain is there. I call it by simply R1. Okay. So here the same thing will happen, and this is R2, and so the same thing will happen, and this is R3. Okay. So this is our structure of triacylglycerol. Okay. The bond which is formed over here, it is a ester bond. It is the ester linkage. The same ester linkage is over here and over here. So this is the structure of triacylglycerol. Now this triacylglycerol, it's a general name of one particular group of compound. Okay, because here we had not specified that what fatty acids are there. It may be many different types of fatty acid we have studied, and any of that fatty acid can take place. Okay, so this triacylglycerol is basically divided into 2 parts. It is divided into 2 parts. One is simple triacylglycerol, and another is mixed triacylglycerol. Now if all these 3 fatty acids are same, so let's say fatty acid 1, it is same as fatty acid 2 and it is same as fatty acid 3. If all 3 fatty acids are same, we call it as a simple triacylglycerol. Let's say for example all these 3 fatty acids are the palmitic acid. Then the resultant triacylglycerol, we give it a name of tripalmitin. Second example, let's say all these fatty acids are the stearic acid. That means at all these 3 positions, this 1, 2nd and 3rd, all these 3 positions, they have stearic acid. At that time we call that resultant triacylglycerol a tristearine. Suppose all 3 fatty acids are the oleic acid, 18 carbon long, and 1 unsaturation point is there in the oleic acid, and so resultant triacylglycerol, its name given is triolein. Okay, this palmitic acid is 16 carbon, stearic acid is 18 carbon, both are saturated fatty acid, and oleic acid is the 18 carbon but with 1 unsaturation point. Okay, so here the naming pattern of the triacylglycerol is very simple. Always remember tripalmitin, tristearine, triolein, all these 3 all these triacylglycerol are of the simple variety. Why? Because all the fatty acids are same in their structure. Whereas if you look at the mixed triacylglycerol, it has two or more than two different fatty acids in the structure of triacylglycerol. Now here the naming pattern will be very much difficult, right? So let's first I draw the one example structure, so our understanding become easier. Suppose this is a glycerol chain, right? This is your glycerol chain. Now it is 3 carbon, we know that. Suppose on the first carbon you have palmitic acid attached by ester linkage. On the second carbon, suppose, and most of the time on the second carbon there is unsaturated fatty acid, right? So as an example I am taking linoleic acid. Suppose on the second carbon we have linoleic acid, and on the third carbon let's say we have stearic acid. So here you can see all 3 fatty acids are different, so we call it as a mixed triacylglycerol, right? So now how to give a name of this compound? This problem was not there with the simple triacylglycerol, right? Because all 3 fatty acids were same, so we had given simple name. But here the trivial name will not work, because there are so many different varieties of this mixed triacylglycerol, so we cannot give all of that compound a different name. So we have to follow some system over here while giving a name to the mixed triacylglycerol. Okay, so in the naming pattern we have to specify location of fatty acid, as well as we have to specify the type of fatty acid which are there in the structure of triacylglycerol, right? Remember, in case of simple triacylglycerol, we don't have to specify the location of fatty acid, right? Why? Because all 3 fatty acids are same and only 3 locations are there, so we can simply refer to the type of fatty acid. So in case of simple, only this type of fatty acids are required in the name specification, whereas in case of mixed triacylglycerol we need what type of fatty acid it is attached and what is the location of it, right? Suppose you have palmitic acid on the third carbon and stearic acid on the first carbon, again that will be a different from this this triacylglycerol, right? So we have to give it a different name. So how we will identify this triacylglycerol? So for that we have to specify the location as well as type. So on the carbon number 1 we have palmitic acid, so I write as its name the one that is a position of palmitic acid, and I have to refer palmitoleiol, 1 palmitoleiol. For the second carbon we have linoleic acid, so I write 1 palmitoleiol, 2 for linoleic acid I have to write linoleiol, 2 linoleiol. So 1 palmitoleiol, 2 linoleiol. Remember, I am specifying position as well as name of fatty acid, okay? And on the third carbon we have stearic acid, so I write stearo, and then we have glycerol, so stearoglycerol. So this is the name of our example fatty acid which is of the mixed variety. So similarly you can give a name to any mixed triacylglycerol if you name its type as well as location of fatty acids, right? Now let's look at the physical properties of this triacylglycerol. Now for the physical properties, again we have to refer to this structure. The first and foremost important physical properties, see this glycerol, it has so many 3 polar group in such a small structure, right? So it is a polar molecule. Glycerol itself is a polar molecule, so it is a water soluble, right? It is a water soluble. What about the fatty acid? Remember, fatty acid also carries this polar group. This COOH is a polar group. It can make a hydrogen bond with the water, so it is soluble in the water. But it has very long aliphatic chain which is non-polar. Okay, so here polar to non-polar ratio is very little. Very little polar group is there with respect to its long aliphatic chain. So again it contains polar group. It has polar group, but one part is soluble in water and bigger part is not soluble in water. So we call it as amphipathic. Okay, and what happens in the triacylglycerol? See, in the triacylglycerol, all this polar group is binding with another polar group of another molecule. So now there are no any polar group in this compound. So your triacylglycerol, it have non-polar. It is non-polar. Why? Because all the polar group had participated in the bond formation. So there are no any free polar group. So as a physical properties, The first physical property, that is the solubility, that it is, this triacylglycerol is non-soluble, or you can say it is non-polar, or you can say it is water insoluble, or you can say it is hydrophobic, all these things means the same in case of triacylglycerol. This triacylglycerol, it is a colorless, physically it is a colorless, it doesn't smell, it is odorless, and it is tasteless, it is a tasteless compound. The third important aspect of the physical properties of the triacylglycerol is that its specific gravity is less than 1. What does it mean? If specific gravity of any substance is less than 1, then it floats on the water. Water has specific gravity of 1. So if any compound has lesser specific gravity than 1, it floats on the water. If some compound has more than 1 specific gravity, it dips under water. It cannot float on the water. The fourth important physical properties of the melting point. It is of the melting point. Now regarding melting point, we know that triacylglycerol, it is a group of compound, it is not a single compound, right? And so many different types of triacylglycerols are there. There are many different types of triacylglycerols are there. So all of them have different melting point, okay? But one thing is common in all the triacylglycerol is that glycerol is common to all, okay? Only variable part is fatty acid. So obviously fatty acid will determine why many different types of triacylglycerol has a different melting point, right? So to understand this, suppose some triacylglycerols are there which has more number of short chain fatty acid, If higher the number of short chain fatty acid, it will have a lower melting point. If some triacylglycerol has a more number of long chain fatty acid, then it will have a higher melting point. So higher the length of chain, higher the melting point, okay? The second important variability with the fatty acid is that if triacylglycerol contains a fatty acid having a high unsaturated or high number of unsaturated fatty acid, then they have a lower melting point. Whereas if high number of saturated fatty acids are there, then they have a higher melting point. Now melting point means the temperature which is required to convert from the solid to the liquid, right? So we know that in triacylglycerol, if there are unsaturated fatty acid, and we know that in unsaturated fatty acid there are production of kink. Why kink? Because of the cis double bond, and this cis double bond doesn't pack nicely in the structure. So when something doesn't pack nice in the structure, its fluidity will be more, okay? Whereas in case of saturated fatty acid, what happens? All are the straight chain fatty acids, so they pack very nicely, very compactly in the structure. So there will be a solid like consistency, right? Okay, now most of the vegetable oils, they contain a triacylglycerol, having a higher unsaturated fatty acid, In earlier videos we had seen that sunflower oil, safflower oil, all they contain a unsaturated fatty acid in the higher quantity. So because of such a high number of unsaturated fatty acid, their melting point is lower, and it is so lower that even at the room temperature, they are liquid in nature. Whereas in case of animal fat, you can take an example of human fat or beef fat. Let's say for example this beef fat, it contains a higher number of saturated fatty acid. Most of the time palmitic acid is there, higher number of saturated fatty acid. And what this saturated fatty acid imparts to the physical property? It gives a solid consistency. It increases the melting point. So at the room temperature, they are solid in nature. This thing we have to keep in the mind. So now as a medical student, why we are studying about this triacylglycerol? What is the function of triacylglycerol in our body? The main function of triacylglycerol is the energy reservoir. Energy reserves. Now you can compare it with one carbohydrate molecule, that is glycogen. Glycogen also acts as an energy reservoir, okay? So what are the basic difference between this triacylglycerol as an energy reserve, this triacylglycerol as an energy reserve, and glycogen as an energy reserve? If you compare triacylglycerol and glycogen, let's first talk about the glycogen. We know that glycogen, it gives a 4 kilocalorie carbohydrate, right? 4 kilocalorie per gram of glycogen, this energy can be released. Whereas in case of triacylglycerol, which is lipid in nature, it gives rise a 9 kilocalorie per gram of fat. Okay, so this is the main difference. And why triacylglycerol is giving more energy than the glycogen per gram? The reason is the carbon in fatty acids are more of the reduced in nature, okay. So they release more energy once they are oxidized, whereas in glycogen they are less reduced, so they releases less energy. So what will happen? Suppose you think about the scenario for storage of 100 kilocalorie, for storage of 100 kilocalorie of energy, how much glycogen is required? The math is simple. You require 25 gram of glycogen, right? Whereas in case of lipid, how much fat is required to store this 100 kilocalorie? So approximately 11 gram of fat is required. So here the difference is very simple, that lesser amount of triacylglycerol can release the same amount of energy if you compare it with the carbohydrate source. The second most important aspect in this is that this glycogen, it's a carbohydrate, right? And it is a hydrophilic compound. It is water soluble compound. So glycogen, when it remains stored in the body, it is not a dry glycogen, it is always along with the water. So it is estimated that 2 to 3 gram of water is there with every gram of glycogen, So here we say that yes, 25 gram of glycogen can give rise to 100 kilocalorie, but actually the double, let's say 2 gram of H2O is required for every gram of glycogen. So along with 25 gram of glycogen, you will have a 50 gram of water. You cannot prevent it. So ultimately, almost 75 gram of carbohydrate along with water is required for the release of this 100 kilocalorie of energy. What is the scene in case of triacylglycerol? We know that triacylglycerol, it's a hydrophobic compound, so no water molecule. So whenever triacylglycerol is stored, the additional water molecules, they are 0 gram. So ultimately only 11 gram of triacylglycerol can store about 100 kilocalorie of energy. So now you can appreciate the difference, that only 11 gram of fat, it will require very less space in our body, and again it will be able to store this much energy, whereas in case of carbohydrate, it requires almost 7 to 8 times higher space or higher weight with respect to lipid. Okay, so mother nature had decided this fats or these lipids as a storage form of energy. But here with the glycogen, there is one advantage, that as it is a water soluble, already a water soluble, so it can be an immediate source of energy, whereas this immediate source of energy, it approximately lasts for 1 day. Whereas if you look at this lipid, it cannot immediately release its all energy, but once it start releasing its energy, it can cope up with the 2 to 3 months of the fasting, So mother nature, see how beautifully they designed our body, that if our body requires an immediate source of energy, it will utilize the glycogen by being a water soluble. So immediately it can be a source of energy, and it can hold up to 1 day. Whereas triacylglycerol, it takes up some time to release its energy, but once it starts, it will remain there for the 2 to 3 months of the fasting. It can cope up, and after that all of your body fat vanishes, so you need to take up some food, or the death can occur. So this was all about the chemistry of triacylglycerol. If you have any query or confusion, please write it down in the comment section below. This handwritten note in the PDF format I had uploaded on my Google Drive, and the link to download this file, you can find it in the video description below. Okay, please like, share and subscribe to my channel. Thank you.